Good morning, everyone. I'm Fabian Torres. This is Norardo, and our project is called CodingChallengeGenerator. Coding challenges have become a de facto standard in the IT industry for technical interviews. And on the other hand, large language models have shown great results at producing texts that are complex, longer, and logical. Our project aims to merge these two worlds and create a generator that can create these challenges on demand and can be used by students, job seekers, competitive coders, maybe recruiters, maybe some teachers. Our source of data is a website called codeforces.com. They publish competitive task coding challenges. We scraped all 8,200 challenges they have. They look like this on the bottom left. It's just a general plain text description, and they also include some tags with the type of problem this is, such as brute force, greedy algorithms, strings, etc. We came up with a set of criteria for evaluating whether we succeed or not. First, it should be written like a coding challenge. Second, it should have little or no ambiguity. It shouldn't be trivial or just the repetition of a definition. It shouldn't have any strange, nonsensical symbols. And ideally, it should be tractable, it should be solvable, but that is very hard to guarantee at scale. So this is an example of a good prompt that we generated. The challenges are very long, but this is one example of one that's titled Feed with Candy. And if you were to read the text, it's about a bear named Carl, I think. He visits a candy factory, he has to hunt some wasps, and there's a set of logical rules. And this is an example of a bad prompt that we generated. Also, it's called Easter eggs, but if you were to read the text, it's about a monster that is trying to hide numbers inside eggs, but then the eggs are also boxes, and they have doors on the side. So this doesn't have internal logic. For our baseline, we used a zero-shot learning with GPT-3. Our best result was with DaVinci, and our prompt looks like this: an elaborate programming challenge about the tag, meaning the type of problem, and the topic, which is the title. Just using DaVinci 3, the one that came out, I think, last week, we found that 72 out of 100 were actual coding challenges. And this is one example. So we asked it to generate a challenge about vampire cricket players and hashing. And in just a few seconds, this is a logical programming challenge about hashing and vampire cricket players.
So now for our model, we use fine-tuning with GPT-3 models, and more specifically Curie and DaVinci models. We sent inputs in the format of tag and title, where we use the title of the data itself, data prompt, and for the tag, we randomly choose one of the set of tags that we have for this specific prompt. And we use a bunch of problems chosen randomly from Codeforces dataset. And the problem text is the completion for our model. So this is an example for the output of the Curie model having a problem about some strings that we need to do some character replacements based on few rules, and we need to know the number of strings at the end. And this is another example for some title of ChallengeGL about some game where they need to play a game having each two colors, and we need to know which player has when based on some rules. So to be able to evaluate these fine-tuning models, we implemented an evaluation classifier where we collected the prompts from our baseline model, and we hand-labeled each of these generated prompts based on the criteria that we've mentioned before. We collected around 400 prompts, where we had 195 labeled as bad and 205 as good prompts. And then we used the min GPT that we had in one of our previous assignments with a learning rate of 5e-5 and 4,200 iterations. And we were able to validate it on 10% of the data and to reach a 75% accuracy that can be improved if we collect even more prompts. So we use this classifier with some hand labeling also to evaluate these fine-tuning models. we reached for the baseline or the zero shot a 72% good performance. For the query fine-tuning, we reached 70%, and for the DaVinci fine-tuning, we reached 77%. So we can see, interestingly, that the zero shot is performing really good. The fine-tuning reached a slightly better performance, like 5% higher, but smaller models like Query didn't perform as good as the other two. The results look promising because we have used only 140 samples for the fine-tuning with DaVinci because of the cost of OpenAI. So considering using more data would absolutely give more promising results for this problem. And thank you.